Okay, now that we have done some equations and we've done some function tables like we did with sequences, and we've written some equations out, we are going to talk about multiple representations. You've done all of these already. Now we're just going to bring it together. So when we have multiple representations, that's 4 different ways to represent a math problem. Okay, so there's 4 different ways that you see math problems. Of course, you have your word problems, and we call that a verbal representation. So verbal is a word problem. Okay. We also have tabular, and we've worked with some of that during sequences already, where we made our tables. Should be a U. Okay. So I'm going to write table here. So tabular is a table. We've also written some equations and solved equations, so there's another way. And lastly, we have drawn graphs just a little bit in here so far this year. Okay, so there's 4 different ways to represent a math problem. The word problem, or the verbal representation, the table form or tabular, an equation, or a graph. Okay, so there's our 4 different ways we're going to be representing our problem. So what we're going to be doing with multiple representation is we are going to be representing one math problem in 4 different ways for each problem. Okay, so first of all, let's talk a little bit more about the function rule. We did a little bit of this in the sequence assignment when you had your X column, your process column, and your Y column. That's called a function rule. So a function rule is a process or a relationship that when you have one value that you put into the process, you get one value out of it. Okay, that's a function. So exactly one input gives you exactly one output on the other side. So that's the vocabulary we're going to use, input and output. And the process we now call the function rule, okay, or the function. So that's what you're going to be hearing as you move on in math. So in a function, we start with an input number. We perform the process or the function, and then we get an output number on the other end, or our answer. Okay. Let's say we had a function rule that was 2x plus 1. Okay? If we have our input, that would be the x part of the table that we were making in sequences. If you recall that table, we had x and y, and then we had the process in the middle. That's a function table. Okay? So our input is x. We have our process, which is the function. And then our output is y. Now the reason that we use x and y is we're going to be graphing this stuff. So this will be our x-axis and that will be our y-axis when we're graphing. So if we have an input of 1, we do our process, 2 times 1 plus 1, and that gives us 3 for an output. If we input 2, that's 2 times 2 plus 1, that's 5 for an output. We input 3, 2 times 3 plus 1, 7. Okay, so this is a function table right here. I've just created a function table with my x input, my process or function, and my y output. All right, here's an example of the verbal and the table portion of a multiple representation problem. Verbally, it says, suppose you earn $5 a week. Make a function table that shows your total earnings after weeks 1, 2, 3, and 4. So we have our input, which is our x, our function rule, that's our process, what we're doing to solve, and then y is our output. So in week 1, we're earning $5 a week. Week 1 is $5 times 1 week for a total earning of 5. Week 2 is $5 times 2 weeks. Our total is 10. Okay, so this is our table representation. We've got the verbal and the table right here in this example so far. Once we've taken our verbal and made a table, we can write an equation or a rule that would be used to determine the total earnings after W, the number of weeks. So for our equation, we can use the variables that are given to us. T is the total earnings, and W is the number of weeks. So T equals total earnings. I'm defining my variables here. W equals number of weeks. Okay, and then my equation, I'm going to look at my process from the previous table. My process was 5 times the number of weeks. Okay, so I took 5 times 1, 5 times 2, 5 times 3. It was 5 times the number of weeks, and that gave me, or that equaled, the total earnings. So I just have to write that out now. 5 times the number of weeks, 5W. When I put that in the input and the process, I got the total earnings. So 5W equals T. That's how we're going to write that equation. We're just simply going to look at our table. I took 5 times the number of weeks equaled the total earnings. 5W equals T. That's my equation. So there's my third representation of my problem in the equation. Finally, I'm going to graph it. Now the input always goes on the x-axis, and if you remember when you set up that function table, it's x and the process and y. Now when we look at the function table, where x is, that's the input value. Then we have our function, and y was the output value. Okay? So it's the same function table with x, the process, and y. Now we're calling it input, function, and output. So the input always goes on the x-axis, and the output always goes on the y-axis. You have to label when you're making your graphs. This one is already labeled with number of weeks on the bottom, total earnings on the left. You need to decide what numbers you're going to put down here. Well, I already know that I had weeks 1 through 4. Okay, I believe, right? Let's check. Yes, weeks 1 through 4 in my table. So I'm going to decide how that's going to look best on my graph. Normally we'll be making a line graph. So I'm going to go every other line here to kind of spread out my numbers. So this is 1, 2, 3, 4 for my number of weeks. And then my numbers for the output go by 5s. Okay, so I think I'm going to make my graph so that every other line is a 5. So I'm going to go 5, 10, 15, 20, and I'm actually going to go up to 25 here. Okay, so in week 1, my total earnings was 5. In week 2, it was 10. So week 1, total earning of 5. Total earnings is over here. Week 2, total earnings of 10. In week 3, my total earnings were 15. And in week 4, my total earnings were 20. All right? And then you're going to take a straight edge. I don't have one right here. I've got to kind of try to draw this. But you're going to take a straight edge, and you're just going to connect these dots together. Okay? Hopefully a little straighter than that. All right, so there's the final representation of the problem, is the graph form. Any of those representations would allow me to solve for an answer, any kind of answer that I needed. Let's do one more example, and then I'm going to let you do the last 2 examples on your own. An armadillo sleeps 19 hours each day. Write an equation using 2 variables to show the relationship between the number of hours, H, and an armadillo sleeps in D days. Okay, so defining my variables for this equation. H equals hours, D equals days. Okay, so they've given me the table already. I don't have to do anything. I don't have to make the table. The input, which we should remember is the x-axis, gives me the number of days. The function rule looks like the number of days times 19. So when I look at the input, that number is right here and here and here. So this is the number of days times 19, and it even comes down here and shows me d times 19. So if the number of days was d, then it would be d times 19, and my output would be 19d, or 19 times days. And then your output is in hours here, and they've given us all that information also. So when I want to actually go and write the equation, I'm just going to look at what I've written up here for process. And I've written number of days multiplied by 19 gives me number of hours. Okay? Number of days times 19 is the number of hours. So, okay, when I write this out, it's going to be 19 times the number of days, 19d, equals h. Okay? Or d times 19 equals h. But when we write out d times 19 in algebra form, it should say 19d. The number comes first, immediately followed by the variable, which means multiply these two together. Okay, so 19d equals h. Now we're going to use the equation. How many hours does the armadillo sleep in 7 days? Okay, so it's given me days. I have to plug that in for d. So this is going to be 19 times 7 equals hours. Okay? Then we're going to figure that out. 9 times 7, 63. Carry the 6. 133 hours with our label, or h if you want to use that, because we already defined that h is equal to hours. Okay? 133 hours every 7 days he sleeps. Now here's our graph. Remember, the input, or the x, goes on the x-axis, and the output, or the y column, goes on the y-axis. So when I'm looking at this graph, or the table over here, sorry, remember x is input, so that's going to be 1, 2, 3 along the bottom. Let me put that in. I'm going to spread it out so it looks nice. 1, I'm going to do it every 3, 2, 3, and I'll even put 4 in here even though I'm not going to use it. Then let's back up and look at, oh, I'm sorry, I missed the label. This is number of days, and I'm going to abbreviate number with the number sign of days. Okay, and then go back. Let me look at the y-axis. The y-axis is the number of hours slept, and it starts at 19 and goes to at least 57. So I'm thinking, if I count by fives, that's about 12 numbers. Let's see. If I do that, I'm just going to have to go 5, 10, 15, 20, 25, 30, 35, 40, 45, 50, 55. That's not bad. So I think I'll do that. I'll count by fives. And my label was number of hours, sorry, writing sideways, slept. Okay? Label it out, 5, 10, 15, 20, 25, 30, 35, 40, 45, 50, 55, 60. Okay. You may choose different numbers than I have on the side to graph, and that's okay, as long as it comes out with a reasonably nice